Hi everyone, thanks for being here. Welcome to this webinar. Today's topic is about LoRaWAN and BACnet interfaces for smart building. If you have any question during my presentation, please feel free to enter them in the chat and I'll be very happy to answer them at the end of this webinar. Before starting, just one number, 2.2 million. That's the amount of money that the university pays every year for its energy consumption. Half of it comes from electricity, and the other half comes from gas, where most of it comes from heating building. So that's why I want to speak about heating building during this webinar, to see how we can reduce this cost. But it's quite a good news to have such a big number, because let's say even a little percentage of saving, 5 or 10%, will be already quite a lot of money, more than 100,000 euros. Great, so today's agenda is the following. There are two worlds, the IoT world, where LoRaWAN belongs, but not only, and there is another world, the automation world, where the BACnet protocol belongs, not only. And today's purpose is to try to put these two worlds together to see how they can fit, to focus on only one objective, is to reduce the energy consumption. When we'll mix LoRaWAN and BACnet, we'll see three different architectures, and for each architecture we'll do a set of demonstrations. My name is Sylvain Montagny. I'm a professor at Savoie Blanc University, and for many years now we've provided educational content about LoRaWAN and IoT. At the beginning it was only for students, but there was a big interest from companies, then we started also to provide trainings for companies and administrations. So that's where the university is, in the French Alps, and in this university, it's the same everywhere else. We have some concern about heating. That's what I've said at the beginning of this webinar. And for that, we are considering putting some temperature sensors to control the water heater. But it's not the only concern. We also have difficulties to control our electricity consumption, energy consumption overall. But also, we would like to reduce the ventilation costs by measuring the air quality. And on other topics, we also have problems during summer, especially with water. When there are leaks, we would like to detect them. And on the security topic, we are concerned about intrusion and about fire alarm. If you look at all these use cases, you can find out that they all have the same characteristic. First, they need to have low power sensors or actuators. Because you want autonomous device, you actually don't want to charge them every week or so. Then the second characteristic is that you want them to be long range. So in smart building, we mostly speak about deep indoor penetration. And finally, there is one characteristic that you don't need at all, is the high bit rate. Because you only send a few bytes every few minutes or so. And that is exactly one LP1R. LP1 stands for low power wide area network. And in this LP1 category, there are 4 good protocols. They are not the only ones, but I'm going to mention only 4. 2 operated one, LTE-M and NB-IoT, and 2 that work in the free band, which are LoRaWAN and Sigfox. But don't get me wrong, I'm not here to say that LoRaWAN is the best, even if I'm going to speak about LoRaWAN today, because it only depends on the use case anyway. But what's nice with LoRaWAN is that you can build your own network. And you don't have to depend on anyone if you want to set up your private network. So if we want to do that, then we need to build a LoRaWAN network. But before, we need to take actions. Taking action can be summarized with this very obvious statement. We can control what we know. What does it mean? It means that the first action is to know. To know is actually putting sensors. Sensors like temperature sensors, air quality sensors, water sensors. And even by putting sensors, what is nice is that you can already save energy consumption. Why is that? Because by putting sensors, you can see all the aberration and dysfunctionment of a system. Let's say, for example, that we've put that at the university. And at the university, as you're never here during the weekend or during the holidays to see if the heater has actually turned on, then you can see when there was a malfunctioning, and you can see whereas the water heater was not controlled properly. So with just measuring things, you can already save some energy consumption. So that's the first action, to know. But of course, if you want to have a real control and save a lot of money, then you need to control. So that's the second action. And if you need to control, you will control based on what value. You will control based on the value that you have monitored before. So the heating control will be done with the temperature sensors. And that will be the same for every use cases. So once you know that, then you need to build your LoRaWAN network. And at the university, we have many flavors of the LoRaWAN networks. We first have a private instance with a Chirpstack network server. For education, we often work with ThinkSpark community, the ThinkStack community, sorry, which is a very good network server for education. When we want to move on advanced topic about LoRaWAN, we often use ThinkSpark by Actility. And finally, we also play a lot with public network with the one provided by Orange. And with that, we can start controlling the heating at the university. But actually, when I say that we can start controlling the heating, it's kind of a lie, because I underlie that nothing has been done before, which is completely wrong. So let's see what's already set up at the university. At the university, we have temperature sensors connected to controllers that are also connected to actuators like water pump and three-way valves. And these BACnet controllers, which are connected with the temperature sensors and with the actuators, they can control more or less the heating of all buildings at the university. Well, it has its limits, but it works pretty well. And actually, if we want to improve this system, the first thing we have to do is to understand it very well, to see how we can improve it. So let's enter the technical room where all the pipes and the boiler are. At the university, we have hundreds of water heaters. How does it work? It's very easy. The hot water comes from the boiler, goes through the water heater, and the cold water goes back to the boiler. Very simple. And for the water to go through the water heater, then we need a pump. And how we can control this pump? Then we can control it based on the outdoor temperature. So we buy a temperature sensors for outdoor. We buy 50 meters of cable. We break through walls, and we finally connect it to the BACnet controller. And the BACnet controller itself is also connected to the water pump. But for some reason, water pumps are not a very good element in the system to control the flow rate. So for that, we use another actuators, which is a three-way valves. And on the figure, I will explain you quickly how it works. It's very easy. If it's exactly how it's represented here, then it's completely open, meaning that all the water goes to the heater and comes back to the boiler. If it's open halfway, then there is half of the water going back to the boiler and half turning around back to the heater. And finally, if it's completely closed, then all the water turns around and cools down by itself. The system is off. Okay, but if you have such a system, there is absolutely no chance to reach the target temperature. Why is that? Because we have many buildings at the university, and they all have a different orientation. Some are oriented south, some are oriented north, some can see the sun, some don't. Some are very old, they have a very bad insulation system, and some are quite new and are much better in that way. So if you want to improve this first system, then you have to provide more data. So you go back to the shop and you buy this time indoor temperature sensors that you will put in every building. Of course, you don't forget to buy another 50 meters of cable each time, because you need to connect this indoor temperature sensor to the BACnet controller. Great. Actually, with this system, it's a little bit better, but for exactly the same reason, you have no chance neither to get the target temperature. Why? Because in the same building, there are many rooms, and rooms are oriented north, rooms are oriented south, some can see the sun, some don't. There are rooms in the first floor, some in the last floor. And it also depends on the equipment of the room. For example, at the university, if you have 30 students with 30 PC, you don't even need a heater in this room. You can believe me. So what we actually need is a terminal adjustment system. In that case, it would be manual for the beginning of this explanation. And with that, you can control every room at the university. If you imagine that among the thousands of students that are entering the room at the university, nobody touches the thermostatic valve, the knob. You imagine also that when a professor finishes his lecture, he will check that nobody is having a lecture behind him, after him, sorry, and if it's the case, he will turn off the heater before leaving during the evening. And imagine now that every day that a professor has a lecture at the university, he comes 1 hour earlier to turn on the heater to be sure that his student will have 90 degrees as a target temperature to work. Then that could work, but it never happens. Instead, what we need something that will control the time where the heater will be on, the heater will be off. It's for the night and day and the holidays. Great. So we have this system also connected to the controller. Actually, it's something inside the controller. And let's see how it works. We have a system with 2 times. Times for the day, starting at 5:30 during the morning, up to 7 p.m. The target temperature is 19 degrees, but as everyone complains, then we usually put 20, even 21 degrees. And during the night, from 7 p.m., the heater stops, and the target temperature is 16 degrees. That makes a heating time per day of 13.5 hours and a heating time per week of 77.5 hours. That could work very well if every room at the university from 8 o'clock to 7 p.m. were completely occupied. So I went on the timetable and I picked up 1 week where the room occupancy is quite high. It's not always like this, believe me, you will see later. But even with such high room occupancy, then we can see that during this week, actually, as an example, Nobody finishes at 7 o'clock, but instead it's a little bit earlier. On Tuesday and Wednesday and Friday it's even earlier. And on Thursday, the lectures start at 10. That makes 9 hours where the heater was on for nobody, 6% of the time. Don't get me wrong, I'm not saying here that during 6% of the time you could turn off the heater, so you're not going to save 6% of your energy consumption, but at least you could, during this 6% of the time, during these 9 hours, put the targeted temperature to 16 instead of 20. So after this week, it was the examination week. And for the same room, look at the room occupancy. Wow, this time there is almost no lectures during the afternoon. On Friday it's very light. This represents 38 hours of heating building for nothing. 56% of the time. Then everyone went on holidays. It was the end of December. And at the beginning of January, everyone went back to the university for the beginning of terms. And at the university, we have different lectures. We have lectures and we have hands-on. And we have room specific for hands-on. And at the beginning of terms, they are not really well used. The room occupancy of a hands-on room at the beginning of January was this one. That represents 61 hours of heating time for nobody, 92% of the time. So what I want to say here is that with the previous system, which is quite good, but we have to improve it by putting a terminal equipment on each heater, but not a manual one, a connected one. And how is it going to set up the set point? The set point will be provided by an algorithm which will get the temperature not on one room, but on many rooms, on all rooms actually. For these thermostatic valves and for these temperature sensors, what do we need? We need something low power, because we don't want to charge this device every week or so. We want something which has long range capability. In smart building, I remind you that we speak about deep indoor capability. And finally, we don't need high bit rate. And you remember that it's exactly what LoRaWAN is good at. So LoRaWAN is going to work side by side with the BACnet protocol, providing more data to the controller so the controller can set up the right set point for every room at the university. But for that, we need to provide the timetable, and that's good because at the university we have the timetable for every room. So instead of putting a timetable with 2 times, the day and the night, then we can provide every time slot for every room at the university. And that's fantastic for BACnet because BACnet has a type of object called schedule object, which is exactly what is on this timetable. So you've understood now that the challenge is to interface LoRaWAN and BACnet to take the best of each one. But the bad news is that LoRaWAN and BACnet have nothing to do with each other. They are completely different protocols. So if we want to interface them, what we need to do is to understand very well how they work. So we'll start with BACnet. BACnet works with an IP network over an IP network, and on my little figure here I've got a BACnet device on the left and I've got a BACnet controller on the right. So let's say that the BACnet device is a temperature sensor. It has 2 temperatures. The first one is 90 degrees and the second one is 28. We can give them to this payload because with BACnet we have names and other properties to each value because we put them in what we call an object. So each value is surrounded by other properties like the name and the unit. And we also have to give a type. So in that case will be an analog value. And when we have many objects with the same type, and we also have to give them a number. So in that case, 0 and 1. And the BACnet controller can ask with a read service the values of the BACnet device. For in this example, it will read the analog value with instance 0, and the BACnet device will answer with the value. That will be stored again in a BACnet object inside the controller. But the controller can also write a value, let's say 30 degrees, and this value will be written in the BACnet device, and the device will just answer OK. In that situation, the device is the BACnet server, and the BACnet controller is the BACnet client. But we can see things the other way around. On the left, we have a BACnet node, and on the right, we have the BACnet controller. And in that case, it's up to the BACnet node to provide data to the controller. So let's say that the BACnet node has an object with a value of 19 degrees, then it can write this value to the BACnet controller with a write service. And the BACnet controller will simply answer OK. Same story for the read operation. The BACnet node can read a value. Here, in that case, it's the analog value with the instance 11, and the BACnet controller will answer with the value, and this value will be stored as a BACnet object on the BACnet node. In that case, the BACnet node is the client, and the BACnet controller is a BACnet server. So why do I explain you that? I explain you this different BACnet client and server because when we'll see the different architectures later, then you will see that sometimes the controller is the client and sometimes the controller is the server. So we need to understand. Great, so let's putting the BACnet now with the LoRaWAN. What we want to do, we want to take the payload provided by the LoRaWAN protocol from our sensors here, for example, and we want to store them in the controller's memory as a BACnet object. When it's from the LoRaWAN to the BACnet, we call that uplinks object. And we also want to work the other way around. So we want to take data from the BACnet controller to the actuators, the LoRaWAN actuators, and we call that downlink capability, so downlink object. All right, okay, so we've seen the BACnet protocol. Let's have a look at the LoRaWAN protocol just in 1 minute. It will be very simple. That's the basic infrastructure. On the left, we have an end device, let's say a temperature sensor. This temperature sensor will send its data using the LoRa modulation. And all gateways in the coverage area will receive this data, and the gateway has no intelligence at all. It simply pushes the data to an instance called the network server, and the network server will take care of the authentication. Then if it passes the authentication, then it will push the data to another server called the application server, which will deal with the decryption. That's all. That's all LoRaWAN is, nothing more. If you want to know more about LoRaWAN, then you can go on our website. There are many free resources, books, and video. You just need to ask, and you will know more about this IoT protocol. But if we were doing a complete IoT project, exclusively LoRaWAN, then we would have wanted to provide our customer a very good user experience. So we'd have pushed our data to an IoT platform. But today it's not the case. We want to push this data to the IoT platform to provide charts and tables and so on. We want to push the payload to a BACnet controller here. And if we want to do that, then we need to build an interface here between the LoRaWAN protocol and the BACnet protocol. Great. So that's what we have to do. Let's simplify this figure first before moving on. I'm going to remove the end device to simplify that. And also on the LoRaWAN part, as the network server and the application server are often in the same place, I will mix them up to call it an LNS, LoRaWAN Network Server. Great. Now for this interface from LoRaWAN to BACnet, there are two requirements. First, the interface and the BACnet controller. Because the BACnet protocol is a local network protocol, they have to be in the same network. There are some workarounds with that if you have the two BACnet hardware in two different protocols, but I'm not going to speak about that during this webinar. So let's say that they have to be in the same local network. And there is another requirement, is that the gateway has to be in the device coverage, which is, I guess, quite obvious. Great, so let's right away start with the first architecture. For the first architecture, what we're going to do, we're going to put all the elements of this architecture in the same box. We're going to put it in the gateway. Well, so it's not a gateway anymore, because the gateway is only the capability to push the data to the LNS, but now I'm going to call it like a box, which has the gateway, the LoRaWAN network server, and the LoRaWAN to BACnet interface. But as you've understood, the first requirement that this had to be in the same local network. With this architecture, the box is the BACnet server and the controller is the BACnet client. So it will be up to the BACnet controller to get the data, to ask and to request the data to the BACnet server, which will be the box. And how can that work? I mean, it's a very plug-and-play solution. You will see it's very easy to use. That's the most plug-and-play solution, the better plug-and-play solution that I'm going to provide today. But there is no magic. If the box can decode the LoRaWAN payload, it means that it has inside the payload decoder. How can it have the payload decoder? That's because the box manufacturer has configured the box with all payload decoder that it wants to support. And there is also the correspondence of the LoRaWAN payload and the BACnet object. So the configuration of this correspondence between the LoRaWAN payload and this BACnet object has been done already. So actually you have nothing to do. So the user journey to set up such a LoRaWAN to BACnet interface is very easy. The only thing to do is to provision the LoRaWAN end device in the LNS. And of course at the end you just have to program your BACnet controller so it can request the data to the box. Easy. There are many hardware like this. Today I'm going to show you 3 that works very well. I will show you a little demonstration for the 3 of them. That's the one I've got on my desk today. But there are others. I can tell you other solutions quickly. So there is the CloudGate from Option. There is the MileSite, which provides also a nice solution. Multitext provides some, Endless, and so on. But today I'm going to speak about the 3 of them here. The Tower by WattSense, the Tau solution provided by Actuality, and the micro IoT solution provided by Y6 Lab. For all these solutions, of course, you have to choose only one of them. You don't have to choose the 3 of them because they can support thousands of, not thousands probably, but hundreds of LoRaWAN devices. Then you have to connect this box, one of these box, I would say, to one BACnet controller. That has to be in the local network again. Come on, let's try a demo. So for this demo, what we're going to do, we're going to do that in 3 little steps. First, I'm going with a BACnet client to check that all these boxes here are present on the network. Okay, so I'm not going to do that with a BACnet controller. I'm going to do that with another tool which will act as a BACnet client. And this tool is very nice. It's called IAB. I just want to show it to you today, so that's why I'm using that. So with this BACnet client, I'm going to check that all the boxes are connected to the local network and are providing the BACnet object with the LoRaWAN device they have already in their network server. Then after, I'm going to provision new LoRaWAN end devices, and finally I'm going to check the new object in the BACnet client here. Great, so what I'm going to do, I'm going to put what I call tempo LoRaWAN sensor in the WattSense. There is already one, I'm going to put a second one. I'm going to put an air quality sensor ATIM device in the Theo solution, and we'll check that there is already one Nexelec air quality sensor in the Y6 Lab solution. So I'm going to change my environment, and there we go. On the left, I've got the 3 boxes. So I've got the WattSense, I've got the ThinkSpark all-in-one, and I've got the micro-IOSys. And the first action was to check that they were all here on the network. So I will check that on the BACnet network. And there we go, they're all here. So I can see my micro-IOSys, which has already one device. I can see the Theo by utility here, and I can see my WattSense here. Great. So I'm gonna start with the WattSense gateway. So I go on this gateway, and the first step is to provision the LoRaWAN end device. So I go on the configuration, and I'm going to add an equipment. You can see that there is already one. It's a LoRaWAN equipment. I'm going to check in the list if it's supported. The one I want to put is what they call tempo. Yeah, it's there. And I need to provide the LoRaWAN credentials. So I provide the dev UI, API, and the key. Then I can submit. So already my device is provisioned, so it was quite fast. And I'm going to select the LoRaWAN payload I want to keep. I don't need to keep them all. And I save. So I need to save this configuration completely in the box because I'm in the cloud so far. I can control that from the cloud. It's not too long usually. Great, the new configuration is in the box, so I can see 2 properties from each LoRaWAN device. And now I can make the property that I want to put in the BACnet side. So I have to add a property from the list. So I can see that there is already a temperature on the list from the other LoRaWAN device. So I want to put this temperature and to push it as a BACnet object on the BACnet side. So again, I save the change and I send it to the box. So once I've done that, while it's saving, I can check that for the moment on the WattSense I've got only one object, which was the Wadeco Tempo 1. But now, yes, there is 2. Okay, the second one has appeared, which is also temperature sensors. And we can wait for the device to join the network. So I need to wait a little bit. It has to join the network and it has to send a value. So it will be updated and I can have the real temperature. Yes, it has joined the network. The temperature is sent. So I've got 19.7 degrees on the first one and Actually, I also have 19.7 degrees on the second one, which is normal because they are in the same room. So that works very well. Now I can do exactly the same with the ThinkSpark all-in-one. I've got another device, so in that case it's pretty much the same story. I add a new device, I give it a name, Atim Tax. It's an air quality sensor. The manufacturer is Atim. It's a tax model. I'm going to give it these credentials, dev UI, and the app key, and I save. It's finished. There is nothing else to do. On this gateway, the correspondence between the LoRaWAN payload and the BACnet object is automatic. I can also configure it if I want, but there is a default configuration, so I don't need to do it. So in that case, I just need to wait for the device to join. It has joined, I can see it. So now I need to wait another payload to come, and here we go. All my BACnet objects are already present. Okay, so I can see, for example, that the value is already there with the time, with the unit, and so on. And if I wanted to do that with the micro-riotis, which is exactly the same, then I would be in this, it's a Chirpstack instance. I would go in this environment, on BACnet environment, and I will add a new device exactly in the same way. You can see that there is already one, an XLX air quality sensor, and I will give it a name, dev UI, join UI, and in the next page I will provide the app key again, the root key, and I would see the new device on my BACnet client here. Great, so that is finished for this demonstration. I'm going back to my presentation. Now I need to explain what are the advantage and the disadvantages of this solution. So the biggest advantage is that it's a fully plug and play solution. All these solutions are really plug and play. All the configuration, the payload decoder has been done. There is always a default configuration to make things easy. It works wonderfully well. You also have some cloud access to some gateways, was the case for the WattSense, for example. And sometimes it'll also come with an IoT platform, at least a little management system. And they also, most of them also support other protocols. And of course, we often speak about Modbus. But they also have disadvantages, and the biggest disadvantage is that it's slightly more expensive than a usual LoRaWAN gateway, and especially if you want to have a bigger coverage, because you have to buy several of these boxes. They work with a finite number of LoRaWAN devices, so if you want to have your custom device, then you either have to ask them to do it, or you have to build your own configuration. And finally, for the downlink capabilities, I've shown you only the uplink capabilities here. For the downlink capabilities, it works, but sometimes it's a little bit more complicated to configure. Great, so that's the end of this first solution. I just remind you the basic infrastructure with the gateway, the LNS, and the LoRaWAN to BACnet interface and the controller. For the first ID, we put everything on the gateway side, but this time I wanted to do that at the university, and I said, well, at the university, I've got already a LoRaWAN network. I've got already a LoRaWAN network server. And I really didn't want to have two separated LoRaWAN network, one for only IoT and one for BACnet. I really wanted to use the one I had already to have only one LoRaWAN network, one and unique LoRaWAN network. So what we've done is that we've kept our network server in the cloud, and we've put the LoRaWAN and BACnet interface in the local network. For that, you need a piece of hardware to support this software LoRaWAN to BACnet interface. So actually, it's a good idea only if you can put that in the controller itself. That makes a very nice solution if you can do that. The problem is that this LoRaWAN to BACnet interface doesn't exist. I mean, this solution exists in the box that we've seen previously, but it's a proprietary solution, so I can't get it and install it somewhere else. So we had to build it ourselves. And we had several requirements when we built it. We wanted it to work with all LoRaWAN and devices with no exception. We wanted it to work with all LoRaWAN gateways with no exception. With the major network servers, things backed by Actuality, TTN, TTS, Chirpstack, and there could be many others. I've got a long list, but they just need to ask if they want to be supported by this solution, as long as they support the LoRaWAN protocol entirely. And it had to work with all BACnet controllers. And today I'm happy that this solution, we wanted to make it open source, and we've released it this morning on my GitHub. So let's have a look closer at this solution. Let's zoom in. Inside, there is a LoRaWAN to BACnet interface and a controller, but this time, whereas the other solution had an interface working as a BACnet server, this time the LoRaWAN to BACnet interface acts as a BACnet client. And that's very different because this time the interface is going to push the BACnet object in the controller. So the controller will not have to get the data. How we can set up such a solution? First, we have to set up what I've called LoRaBAC, which is the name of this interface. It works on a Node-RED flow, so you have to install Node-RED. Node-RED, for those who don't know, is a software, a no-code software, meaning that you have to connect nodes together to build your application. But this application, you don't have to build it because I provide it. You'd have to import the LoRaBAC flow from my GitHub and to configure it. So what kind of configuration do you have to provide? The first configuration is to tell which network server you want to use. So you can use Chirpstack or TTS, TTN, or Actuality. And you also have, because it can work with many different BACnet controller at the same time, you have to provide the IP address of the BACnet controller where you want to push your data. And you also have to say with which protocol you want to work. So for the moment, it works with native BACnet, which is the one I'm presenting here today. But also it works with some controller which can support the REST API. That makes something much powerful. And for the configuration of the name BACnet, just consider it as a hint for in the near future, there would be probably other protocols supported, hopefully Modbus. And once you've configured that, then you're done if the device is already supported by the solution. But if it's not, there is no magic that you have to provide your own configuration. And what is the configuration? You have to explain exactly in the same way the box manufacturers have done in their box, and you have to do it exactly that to configure the association between the LoRaWAN payload and the BACnet object. So what is the correspondence? So for example, if you have a temperature sensor with 3 LoRaWAN payload inside, current temp, min temp, and max temp, then you have to give a name for each of them of this payload. Let's say current temp, min temp, max temp, obviously. You have to give them a type because a BACnet object has a type, and you have to give them a number. You have to do this configuration only once for all your LoRaWAN devices, meaning that if you have 500 of a temperature sensor, you have to do this configuration only one, because the real number that will be affected to the BACnet object is based on the sensor number. So if you provision on the network server the sensor number 0, then the instance number that will be affected will be 0, 1, and 2, And if it's sensor 1, it will be 10, 11, 12. And if it's sensor 2, it will be 20, 21, 22. That can be configured over, obviously, but once you've done it once, you don't have to do it for the others. So this solution supports all the thermostatic valves that I know, actually the one I've been able to get. So the Micropel, the new Dome Pilot smart home thermostatic valve, which can also measure the energy consumption of each handpoint, the MClimate, the MileSight, and of course it also supports the many other LoRaWAN devices. And the last step is the same one as the others. You need to provision your device in the LoRaWAN network server. Nobody can do that for you anyway. Great, so maybe you want a demo. Okay, so as a device, I'm going to use a thermostatic valve, but I'm going to use a thermostatic valve that has been built by the university. So this is a real LoRaWAN device with a real thermostatic valve firmware, but it has no mechanic, okay? It just provides two data. The first data is the set point of the valve, the actual set point of the valve, and the second one is the temperature of the valve. That is the uplink object. So the uplink data that the valve provides, and it receives, so it pushes the set point and the temperature, and it receives the set point that was stored in the controller. So for the controller, what I'm going to use Distech Control Eclipse Apex, and I'm going to install here inside. So it's done already, but I'm going to show you how works this interface is the interface from LoRaWAN to BACnet inside the controller. Great, so the demonstration, there will be 3 little steps then. First, choose a device from the list. So that's been chosen already. So it would be this device. Okay, so that's done. Provision a new LoRaWAN device on Chirpstack, because on this solution, I'm going to use Chirpstack as a network server. So that's going to be very quick. And then after that, it's finished. We just have to check the configuration, the BACnet object, sorry, in the controller. So the BACnet object will be created in the controller, and we'll just have to check if it has been created, and eventually modify it so we can see the set point going back to the thermostatic valve. Great. So let's change the environment for the test. Okay, so on the left, I've got my LoRaWAN device. So it hasn't been provisioned on the network server already, so the join is failed. That will change in the near future. And on the right, I've got as different windows. I've got my LoRaWAN network server, which is in the cloud here. It's a Chirpstack instance. Then I've got my LoRaWAN to BACnet interface, which gets the data from the network server to get the LoRaWAN payload. Then this LoRaWAN payload is transformed as a BACnet object and pushed in the controller. So I've got many objects already in this controller because I've got already a lot of devices running at the university. But I'm going to filter on the one I'm going to enter because I want you to see it appearing on the screen here on the dashboard. So the first step is to provision a new network, a new LoRaWAN device. So I'm going to add a new one. I need to give it a name. So it's USMB valve. I'm going to give it a number. Let's say the number 1. Then I need to provide, as usual, the dev UI, join UI, and the app key is in the next window. I give it a device profile, so I've entered already the payload decoder. Then I need to provide the app key here, so it's generated app key, so you don't have to worry about security. And that's done. Right, it's done. So I'm just need to check if my device is going to join. So I need to wait a little bit for it to join. And when it will join, I will see that, yeah, it has joined. It has sent a new frame. So now you can see that some BACnet objects have been created. So it has received the LoRaWAN payload, and on the controller, new objects have been created already. And as you see, when it started with a set point of 19 degrees, whereas on the controller the set point was 20 degrees. So it has bring this set point from the controller to the thermostatic valve. So now I can, let's say, change this value if I want to be hotter, 25 degrees. Then I need to wait for the next frame to come up, so I can help it a little bit. In the interface, it will check that there is a schedule, because the set point on the valve is not the same as the set point on the controller. And here we go, we've received the new set point on the valve. So that's the way it works. Now if you imagine that you want to have another device, so let's say USB valve number 2, I'm not provisioning another one, I'm just using the same one but just changing the name. Then if you go there at the next uplink, I can help it a little bit, then they will be recognized as a new LoRaWAN device in the LoRaWAN to BACnet interface, and the object will be created. Here we go. Yes, here it's been created. Great, so that's all for this demonstration. So back on the presentation. So we've seen with this demo how this LoRaBAC interface worked. Let's see now the advantages and the disadvantages. The biggest advantage is that you can use this solution with an existing LoRaWAN network. And it's the case for a lot of administration collectivities and some people who have already an IoT project running. So you can use your own LoRaWAN network. It's free, open source, and under the MIT license, so it's very permissive. And what's also nice is that you don't have to rely on anyone to support new devices. But there are, of course, disadvantages, and quite big ones. It's that you need to install something which is maybe a bit technical for people who don't know. So even if we have a good documentation, it's a big step forward to try to install such software. It's not complicated, but still you have to do it. So it needs more technical background, definitely. Great, so let's move on the next and the last architecture. So don't worry, because the last architecture is exactly the same, except that let's remind what we've done. We've put everything in the gateway. Then we said, okay, we want to use our own network server. So we put the network server in the cloud, and we've used the interface in the controller. Now, what we're going to do, we're going to put everything as a single point in the controller. So the LoRaWAN network server will be installed in the controller itself. For this solution, we've tried with many options. We've tried with the ThinkStack, with Chirpstack in the controller, but there is no reason for why you couldn't use proprietary network server. We've used LoRaBAC for the interface, and as a controller, we've used on 2 controllers, the Eclipse Apex from District Control, the one we've just used, and we've tried that also on the PFC 200 from Wago. So I'm pretty sure you want a demo. So for the demo, I'm going to use the same thermostatic valve that we've used so far, so the one provided by the University. We're going to use the Eclipse Apex provided by District Control. This is the same one I've used previously. And for this demonstration, there will be 3 steps again. So the first one is done already because I've chosen my device. Then I need to provision this device on the ThinkStack. So this time I'm going to use the ThinkStack because previously we've used Chirpstack. So I've installed here the ThinkStack. And finally, we will use the controller to check that all the BACnet object, again with the same, exactly the same demonstration, that the BACnet object have been forwarded to the controller, and that the controller can also send new set point to the valve. So let's try that. I'm changing my environment, and in the same way I've got exactly the same windows as previously. I've got on the left my LoRaWAN device, which is trying to join. Obviously it fails because the device is not provisioned on the network server yet. It will be done shortly. We're going to use this time the thermostatic, but this time the thermostatic is set up on my controller locally. Then it will push the data to my LoRaWAN to BACnet interface, which is this Node-RED flow. And then this flow is going to push the BACnet object directly to my BACnet controller. Great, so the first step is to provision the BACnet, the LoRaWAN device in the network server. I've got an application already, so I just need to register a new end device. I'm going to do it manually, quickly, 1.0.3. So I need to provide the join UI. I need to provide, as usual, the dev UI and the app key. The interface works on devices based on the name, so I need to give it a name, USMB valve, and I'm going to get the same number, let's say, valve number 1. So it's registered. Now the end device is going to try to join. The join has been pushed already, so I think it's going to join shortly. Yes, the join has been pushed and the data has been sent. So maybe, yeah, we've seen that. So the BACnet object has been created already, and so I should see them, yes, in the BACnet controller. So it's done. So it's just exactly the same story. It works in exactly the same way. Great. So when we play with that, we have exactly this kind of dashboard. We've played with it, so we can see the change of set point over the time. And we've tried to change every on a room that on a room where there were nobody. We changed the set point from one to another every hour, to see if the set point was following, the set point from the valve was following the set point from the controller. And you can see that there is a slight delay, which is due to the LoRaWAN protocol. Otherwise, it works very perfectly. And we've worked with this thermostatic valve of many, so with almost all of them. And we've also worked with temperature sensors, current sensors, and so on. Great, so that's all for this demonstration. So let's move back to the explanation, to the webinar. So now there is also, as usual, some advantages and disadvantages. The advantage is that you can use any LoRaWAN gateway. And the biggest advantage is that you can have a unique point to deal with your IoT devices, LoRaWAN devices, and your automation process. So you've got a unique hardware for everything. And what's nice also is that if you use the network server I've used, then you can have advanced features of a LoRaWAN network server, like for example the LoRaWAN relay, or you can even do some roaming between your network server. If you have different buildings with different network server, then you can get the data from one to another. That's advanced topic. I'm not going to speak about that anyway during this webinar. Great, and there is also, of course, disadvantages. Previously, for the previous demonstration, we had to install Node-RED, but now we have to install Node-RED and an LNS on the network server. So, which is another step, another technical step that you need to handle. So obviously there is more configuration than the previous one, and much more configuration than the plug-and-play solution provided by the box's manufacturer. All right, so I'm happy to tell you that it's almost over. But just to keep in mind what was the purpose of this webinar. This webinar wanted to tell you how we could reduce costs. And how we can do that, we can reduce the costs only by providing new data to feed our BACnet controller. And for that, LoRaWAN and BACnet have nothing to do each other, but they can work together on the only purpose to reduce the energy consumption. Well, to finish, if you want to practice, then you can ask us. We have LoRaWAN trainings, and we have also LoRaWAN to BACnet trainings with a lot of hands-on, so you can take care of this solution and build them by yourself. Thank you very much for your attention.